Okay, this is 6.2 notes naming ionic compounds. We're going to go ahead and do this in our notebook because, quite frankly, the notes that are provided, the worksheet is just not very good. So I'm going to try to make this as easy as possible, and we're going to start with the example that we're already familiar with, which is fluorine. We're going to start with the halogens. Specifically, we're going to start with fluorine right here. Okay, we know that all of these guys have they have 7 valence electrons. They only need 1 more valence electron to become like the noble gases. So instead of drawing out the Bohr model, I just drew out their valence electrons, and you can do the same. Make sure that you pair them up like so. Okay, on 4 sides. Draw an imaginary. You can imagine a square around that, and then pair up the electrons like so around each side. And then there's 1 lone electron there by itself. That's fluorine. If fluorine picks up an extra electron like that, it has a charge. It becomes an ion, right? Because it just picked up that extra electron. And what we call it is fluoride. Its name changes to fluoride. Okay, and it's no longer fluorine, it's now fluoride, and it's not dangerous anymore. Okay, we can use it in our toothpaste. That's fluorine. Well, the same applies for the rest of the halogens. The same applies for the rest of the halogens. I'll draw them out right now, and then we can look at them. Okay, here's the rest of the halogens. Chlorine with 7 valence electrons, 2, 4, 6, and 7. If it picks up another valence electron, it gets a charge, and we call it chloride. Make sure you write these in, just like I am. Bromine, if it picks up an extra electron, it gets a charge, and it becomes bromide. Iodine, iodide. Okay, so now let's see, each one of these has a charge of -1. So what could we pair them with on the periodic table? Well, they'd pair very nicely with all of these, wouldn't they? These group 1 elements. And the metals, whenever these guys pick up, or rather when they lose an electron and they gain a charge, a positive charge, we don't need to worry about changing their names. So lithium, the lithium ion is just lithium. Okay, so let's go ahead and do a few examples with lithium, sodium, and potassium. So if we had lithium, it's got a +1 charge if it loses its electron. With chlorine that picked up that extra electron, it would become lithium chloride. LiCl is lithium. Lithium chloride. Or K, potassium, can lose 1 electron, and it can be picked up by, well, chlorine, bromine, iodine, any of them. We can just say K with an I negative. Okay. That's going to be potassium iodide. Potassium iodide. What about, let's do one like this, NaCl. That's sodium chloride, or table salt. Sodium chloride. What about, let's work backwards now. Let's say potassium bromide. Potassium bromide. Well, that's K, potassium, and bromine, Br, like so. Okay, well, that's fairly easy. What about magnesium iodide? Now, before you just write in Mg, you have to look at the periodic table here and see that Mg loses 2 electrons. Everything in this row will lose 2 electrons. So Mg, the charge for Mg would actually look like this. Mg, because it loses 2 electrons, it's going to have a +2 charge. Okay, and iodine, because it gains 1 electron, has a -1 charge, and these two charges are not balanced. So what you have to do then is balance these two charges out, and the way you would do that is you need to make this a -2, and by doing that, the only way to make that a -2 is to add a second iodine molecule or atom there. Okay, you'd have to put it in as a subscript like so. So now you've got 2 negative charges, cancels out this 2 positive charges, this +2 charge. So it would look like this: Mg I2. Let's try magnesium. Oops, magnesium fluoride. Magnesium fluoride. Let's try that one. Okay, again, magnesium has a +2 charge. Fluorine has a -1. Sorry, fluoride has a -1. So I'm going to need 2 of these fluoride atoms to cancel out this +2 charge. Okay, so my formula is going to look like this: MgF2. MgF2. Okay, the same thing goes for calcium as well. Beryllium, magnesium, calcium, strontium, barium, all of those form a +2 ion, +2 charge. So let's try one. Let's try one with strontium. Strontium chloride. Let's do that one. Strontium chloride. So again, look on your periodic table and let's see if I have a pen. I don't have a pen. Okay, you can just make a little note. These form +1. That forms a +2. Okay, everything in this column here, +2. Over here, +3. Skip that. And then that's -2, -1. Okay. So back to strontium chloride. Strontium is right there. So it's going to be Sr. And that's +2. Chlorine, or chloride rather, is a -1. We need 2 of these to cancel that out. So I'm going to put a 2 there. So my formula is going to be, Sr Cl2, strontium chloride. Okay, so we're almost done. Let's look at the oxygen forms oxide, sulfur forms sulfide. And really that's pretty much it. Sometimes you'll see a nitride. Okay, but let's look at the situation with oxygen. Let's say we've got potassium oxide. Potassium oxide. The IDE tells you that that's an ion. That's what that tells you. Instead of oxygen, it's oxide. Tells you it's an ion, and when oxygen forms an ion, it's got a -2 charge. Why? You can draw out the Bohr model and look for yourself, but it's got 6 valence electrons and needs 2 more, okay, to have that 8 in the outer shell. So therefore it forms an oxide. So let's go ahead and do potassium oxide. Potassium is K, and it's in the +1 column. oxygen forms oxide, O, and that's a 2 minus. So now look, we've got a -2 charge, a +1. We need to cancel out that -2, so the way we do that is we add 2 of these potassiums. That now becomes +2, cancels out the -2. So our formula looks like this. K2O, that's potassium oxide. You're going to get a list of ions. You'll note some of these ions have multiple atoms, and these are called polyatomic ions. So for example, this one right there, permanganate. Unfortunately, you're just going to have to memorize that, permanganate, and you're going to have to see what the charge is. Well, actually, you're not going to have to memorize it because it'll be given to you on your test, I believe. This will. But it's a good idea to just know that what permanganate is, what phosphate is, what sulfate is. Okay, so we'll make some flashcards for you on Quizlet. And these polyatomic ions work the exact same way that these single ions did. Some of them have a +2 charge, some of them have a -2 charge, some of them have a -1 or a -3. And the goal is always to cancel out, make sure that whatever you're pairing it with, whatever metal that you're pairing this with, cancels. So potassium phosphate, KPO4, well, let's just do that. Let's do potassium and phosphate together, shall we? Potassium's got a +1 charge when it forms an ion, and phosphate, PO4, where is it? Phosphate right there has a -3 charge. So it's PO4, and it's got a -3 charge. Okay, so we're going to need 3 of these to cancel out that -3. So our formula is going to look like this: K3 PO4. Okay, now sometimes you might need multiple polyatomic ions, and when you do, you have to put those in parentheses like that. If you need more of these negative anions, you're going to have to put them in parentheses like that. Okay, something that might look like that. If you need an example of how to do this, come and see me in person. I think it might be easier that way. Okay, thanks.